All right, guys, we're going over our Unit 3 Expressions Test Study Guide. So we're starting with this slide, which is identifying parts of an expression. So remember that terms are all the pieces of an expression. They are separated by addition or subtraction signs. In this case, we just have a bunch of addition signs. So our terms are going to be all of the items, 2a, 5b, 4b, and 7. Our variables are going to be our letters that we see, so A and B are going to be our letters. We don't have to write B twice, we just have to write it once. For coefficients, those are going to be the numbers that accompany the letters or are next to those letters. So that would be 2, 5, and then don't forget there's a 1 in front of that B. Our constants, those are our constantly alones, our solo guys, so that would be 4 and 7. And then for our like terms, we've done this before several times. Our like terms are going to be, they have the same variable and they have to also be raised to the same power, or they can be just numbers. So I have a pair of like terms with the 4 and the 7. And then separately, I have another pair of like terms, and that would be our 5b and our 1b. So 5b and 1b. The A does not have anything that goes with it, so there are no like terms to go with the A. All right, our next slide here is asking us to simplify the expression by combining like terms. So if I use my train method, separate my terms, I'm going to look and see what my like terms are. So we just talked about this in the last slide. It's the same expression. So 5b and 1b, we can combine those to get a total of 6b. And then the second set of terms that we can combine are this 4 and 7, which would give us plus 4 plus 7 is 11. And then this 2a doesn't have anything, so we're just going to bring it down. And that's as simplified as it can get. For our next one, same thing. Separate all of our terms. Okay, our like terms here are going to be our 4f squared and our 11f squared. Remember, it's got to have the same letter raised to the same power. Separately, we have a 3f and a 1f. That's a set of like terms. And then 6 is kind of on his own or here. He doesn't have anyone to go with. So now when we combine like terms, 11f squared plus 4f squared would give me 15f squared. So that's those guys. And then 3f squared, or sorry, 3f plus 1f would give us plus 4f. And then all I have left is my plus 6, which I will just rewrite. So that is simplified. Now on this one, we're still simplifying the expression. So this first one, we're just combining all these m's together. And if you remember that if you have a letter just by itself, there is an imaginary 1 in front of it. So we're really doing 1m plus 1m plus 1m plus 1m plus 1m, which would give us a total of 1, 2, 3, 4, 5 m's. Now this is different than the one below where we still have our 1's in front of our m's, but instead of those 1's being added, they're being multiplied. So we're multiplying 1m times itself, 1, 2, 3, 4, 5. So the way that we would write that is m to the 5th power. You can write 1m to the 5th power if you'd like. It means the same thing. All right, now let's take a look at these. These are a little bit different. We've got some parentheses here. So remember, if you have parentheses and a number right outside of it, we are going to distribute, which means to multiply what's on the outside by everything on the inside. So we need to do 9 times 3, which will give us 27, plus, and then 9 times 4 would give us 36, and that's a 4w. So 9 times 4w will give us 36w. And then since our 12w plus 12w is outside of the parentheses, we're just going to rewrite that and bring it down. And then we will combine like terms. So if I look, I have one set of like terms here, which would be our 36w and our 12w. So we would add those together to get 48w, and then plus our 27, we would bring that down. Okay, we're going to do the same thing for the bottom one, but we're multiplying a 2a inside our parentheses. So 2a times 5a would give me 10a squared, remember because you're doing a times a, plus 2a times 7 would give me 14a, and then plus 6a squared. And then again, we're going to combine like terms here. So if I look, I've got a 10a squared, and I've got a 6a squared. So we'll combine those together, and that would give me a total of 16a squared. And then my 14a, we're just going to bring that guy down. And that is done. All right, now these are a little bit different, and we are going to be using our GCF to write equivalent expressions with distributive property. So first thing we need to do, remember, is to find our GCF. So we're going to do our factors of 24 and our factors of 16 and find the greatest one. So our factors of 24 would be 1 and 24, 2 and 12, 3 and 8, 6 and 4, or 4 and 6, and then we're done. For 16, we have 1 and 16, 2 and 8, and then 4 and 4, and we are done. And we can see here that the greatest common factor is 8. So that number is going to go on the outside of our parentheses. And then we're going to put the leftover factors inside of our parentheses. So since the 3 was with the 24, we're going to write 3 plus. And then the 2 was with the 16, but that's a 16k, so it's going to be 3 plus 2k inside. Now the same thing is true for our 25 here and our 15. So we're going to list out our factors of 25, list out your factors of 15. Factors of 25 are 1 and 25, and then 5 and 5, and that's it. And then factors of 15 are 1 and 15, and 3 and 5. So we can see here that the greatest common factor is going to be 5. So the 5 is going to go on the outside of our parentheses, and then we have to determine what stays inside. So if we take a look, we've got 25b. So the other factor is 5, and then it's going to be a 5b plus. Our 15 was an a squared. Our other factor is 3, so it's going to be a 3a squared. And that is it. All right, we are going to solve using order of operations. So the first thing we're going to do is work inside of our parentheses here. So we are going to do division first because we have to follow PEMDAS. So parentheses and then keep following PEMDAS inside the parentheses. So 6 divided by 2 is 3. We're going to bring down everything that we don't use here. 7 minus 3 is going to be the next thing that we do, which would give us 4. I'm going to bring down the rest. After we do parentheses, next is exponents, so we are going to do 4 squared, which is just 4 times 4, which will give us 16. And then 16 times 4 is the last step, which will give us 64 as our final answer. All right, for this one, we are going to follow order of operations again. So the first thing we're going to do is divide, because remember, if you've got multiplication and division, you will go from left to right. So 16 divided by 4 is 4. I'll bring down everything else. My next step would be to multiply 4 times 2, which is 8. Bring down what we didn't use. Now we're in between some subtraction and addition, so we are going to subtract first. So 25 minus 8 will give me 17. And then we're going to do the plus 9 as our last step, which would give me 26. Okay, for this one, we're going to do in our parentheses first, which is 4 plus 5 plus 4, which is 9. And then we're going to square it, minus 17. 9 squared is 9 times 9, which is 81, minus 17. And then 81 minus 17. I have to borrow. Okay, and this becomes a 4 and a 6, so 64. Okay, for this one, they gave us an expression. We're going to plug in the values that they gave us. So we're going to put an x, or sorry, a 2 where the x is and a 5 where the y is. So I'm going to rewrite it as 2 plus 5 in parentheses, that's all squared, minus 12. So our first step here is to work in our parentheses. So we're going to do 2 plus 5. 2 plus 5 is 7. we're going to do 7 squared minus 12. So order of operations, after we do parentheses, we do need to do the exponent. So we're going to do 7 squared, which remember 7 squared is just 7 times 7, which will give us 49. So 49 minus 12. And then we need to subtract 49 and 12 for our last step. So over off to the side, let's do a little math here. 49 minus 12, which would give us 37. All right, we're going to do the same thing for the next one. We're going to plug in a 3 for our B and a 5 for our C. So I'm going to rewrite it as 4. Now remember, that's times if you've got a number and a letter smushed together. So 4 times 3 plus, and then C is 5 squared. Oh, that 3 is squared as well. So it's 4 times 3 squared plus 5 squared. Okay, order of operations tells us we need to do our exponents first. So 3 squared is what I'm going to do first, which is 3 times 3, which is 9. I'm going to bring down everything else. I still have another exponent here, which is my 5 squared, so I'm going to do that next, which is 5 times 5, which is 25. So 25 plus, and then 9. So bring down everything else. Order of operations tells us we are going to next do our multiplication. So we're going to do 9 times 4, which does give us 36. And then we're going to do 36 plus 25 to get our final answer. So 36, 25, we get 11. Oops, 61 is our answer here. Okay, for this next one, we are plugging in our length, which is 8. We're going to do 2 times 8, our length, and then plus 2 times 10, our width. So 2 times 8 plus 2 times 10. So we are going to do 2 times 8 first, which is 16, plus 2 times 10. Then we're going to do 2 times 10, so 16 plus 20, which would give us our final answer of 36. For the next one, Rita drove 55 miles per hour to the mountains. If she drove 5 hours, how many miles did she drive? So 55 is our rate. We're going to plug that in for R, and 5 is our time, so that's T. So we're doing 55 times 5 to figure out the distance, which how many miles will she drive. 55 times 5 is going to give us 275 as our distance. All right, so we are just solving for these. So we've got 5 to the third power, which is just 5 times 5 times 5. And then we've got 6 to the fourth power, so that's 6 times 6 times 6 times 6. All right, so if we do 5 times 5, we get 25, and then 25 times 5 is going to give me 125. And then for 6 times 6, that's 36, times 6 times 6. 36 times 6 is going to give me 216 times 6. That's going to give me 1,296. All right, for this last slide, I've already filled it out, but I'm going to talk you through it. The first one is C because you can see the order of our number has changed, so that's going to be the commutative property of addition. The next one down is going to be the identity property of multiplication because I multiplied by 1 and I kept the value of 15x the same. The next one is commutative property again because our order has changed, but this is now of multiplication, so that's D. The next one down is zero property because I multiplied a number by 0 to get 0. The next one is the associative property because you can see my groups have changed, but the order has stayed the same. The next one down is going to be an identity property of addition because I added 0 to a number to keep it the same. The next one down is going to be the associative property of multiplication because, again, my groups or my parentheses have changed, but the order has not. And then the last one is going to be distributive property because I took that number on the outside and multiplied it by everything on the inside of the parentheses.